Hey guys, hope you're doing well. I miss you. I'm having a lot of fun, but I miss you. I'm gonna go kind of quick, but I'm gonna work through each question and just talk about what I'm doing. So the first one says the perimeter of triangle PQR is 58 feet, so that's the whole thing. PR is 28, PQ is 15. Well, if the whole thing's 58, then I would do 58 minus 15 minus 28. 58 minus 20. Minus 8 would be 50, minus 20 would be 30, so that's 15. So it would seem like that whole side is 15. I'm going to confirm that. I don't want to mess up. 58 minus 28 minus 15 leaves me with 15. Perfect. Find the length of QL. So I'm going to put an X on QL. So this is an angle bisector situation. If that's 15, like what if I told you this was 6? Wouldn't you do 15 minus 6 and say this is 9? But we don't know that it's 6. We know that it's X. You treat X just like you would treat a number. It's 15 minus whatever X is. You do big minus small. Don't say X minus 15. You wouldn't say little minus big. That'd be a negative number. Come on, guys. It's 15 minus X. We got this. So angle bisectors, we do side over side, 28 over 15, equals part over part, 15 minus X over X. I don't see anything here that reduces, so we're going to have to cross multiply. That'd be 225 minus 15x equals 28x. That'd be 225 equals 28, 33, 43x. Divide by 43. I don't know if that's going to simplify. 225 over 43, and it does not. So that is just our answer. So QL is 225 over 43. Yummy. They tell us these two are similar. Pay attention to the order. So like CB, if you look here, CB goes with GH. Now those are the only two that were on the picture, so hopefully you don't mess that up. But if there were more things, you have to pay close attention. The similarity ratio is 2 to 3. Find X as well as the area and perimeter of ABCD. Well, if the ratio is 2 to 3, that is the similarity ratio. I'll put up here. The similarity ratio is 2 to 3. That means that the perimeter ratio is also 2 to 3. And that means that the area ratio, if you remember, squared ratios, squared units, we're going to have to square the 2/3. And that's going to equal 4 over 9. So when we work with area, we got to do 4 over 9. So we have three proportions we're going to set up here. First, we're going to say that 2 over 3, and remember, that's in the order that they named them in, so that's 2 to 3. 2 over 3 is going to equal 4x over 2x plus 12. Well, I can reduce 2 and 4 to 1 and 2. I can reduce 2, 2, 2, 12 to 1, 1, 6. And so I'm left with 3x equals x plus 6. So 2x equals 6, so x equals 3. Boom, got it. Perimeter, I'll change colors up. The perimeter number here is 200. That's on the bigger shape. So for perimeter, I'm going to do 2 over 3 again, same ratio. I'm not going to use x because we've already used x. I'll say y, the perimeter is y over 200. Nothing reduces there, so 400 equals 3y, and that would be y would equal 400 over 3. So the perimeter would be 400 over 3. The area, let's change it up again. For area, we have to use the ratio 4 over 9. And the area over here is 500. So I'm going to call that W for whatever reason. W over 500. Again, it doesn't really reduce. I don't think. No, it doesn't. So that would mean 9W equals 22,000. So that does not reduce, I don't think. Let me just type it in. 2,000 divided by 9. No, it doesn't reduce. It's just 2,000 over 9. So 2,000 over 9. There are your answers. Boom. Killed it. Next situation. Ooh, okay. 125-foot shadow for the tree. 4 foot 10, 5 foot 6 inches for the girl. So first off, 4 foot 10 would be 4 plus 10 over 12, which is 4 plus 5 out of 6. Clean that up. That would be 24 plus 5 would be 29 over 6. So she is 29 over 6. That's the number I would use. And then they already put 5.5 there, sure. You guys have calculators, not a big deal. So it's going to be her height, 29 over 6, divided by her shadow. They called it 5.5. I'll call it 5.5, sure. As long as you're not rounding, that's okay. Equals the tree's height, which we don't know, over the tree's shadow, which is 125. I would just use your calculator and cross multiply. 5.5x, 125 times 29 over 6. I get a weird, I shouldn't have said weird, I'm so sorry. I get a number 3625 over 6. I'm going to divide that by 5.5. And I get the tree height, says right as a fraction, so that would be 3625 over 33. That's a lot of fun. Parallel line situations. The spaces between the parallel lines all have to have the same ratio. So 4 over 3 has to equal 6 over 2y. I can reduce 4 and 6 to 2/3. And that's all I can really do. Cross multiply, I get 4y equals 9. So y equals 9 over 4. Y equals 9 over 4. Oh, they wanted the reason that they're similar? Well, if the lines are parallel, then corresponding angles are going to be equal. So the reason is angle, angle. And then to get x, x is on the actual parallel line. So we have to focus on the big triangle. So 15, the bottom of the big triangle, has to go over 10, the left of the big triangle. And that would equal 2 minus x, the small triangle bottom, over 4, the big triangle bottom. That's the proportion based off the picture. 4 and 10 reduce to 2 and 5. 5 and 15 reduce to 1 and 3. So you get 2 minus x equals 6. So you get x equals -4. Nope. You get x equals -4. Yeah, you do. You get x equals -4. It's okay for x to be negative. When you plug in -4, 2 minus -4 would be 6, which is what it needs to be. So there we go. X equals -4 on that one. All right, this is a tough one. Here we go. Let's get it. We have 3 similar triangles. We did one like this in class with 2 similar triangles. This one has 3. It can be hard to tell which angles go together. So what I would do is make up a number. I'm not saying this angle is 10 degrees, but I'm going to make it up. I'm going to say it's 10 degrees. Well, if you look at the biggest triangle, this corner's 90, this corner's 10. That means this corner up here would have to be 80. That's 90, so this angle next to it would have to also be 90. So we have 2 90s here. If we go off this small triangle down here, this would have to be 80, and that would make this 10. So here's the bottom line, guys. We know that this angle, I don't know that it's 80, I made that up, but I do know that whatever it is, it's the same size as this one. And this angle over here, I'll give it a double dash, has to be the same size as this one. That's what I know. And I know that there's 3 triangles here. They all have a 90, a single dash, and a double dash, or a 90, an 80, and a 10. So I'm actually going to redraw 3 right triangles. So this takes a little bit of time. And I'm going to put the same angles in the same place. I'm going to put the single at the top and the double at the bottom for all of them. So for the biggest triangle, the single is A, the 90 is B, and the double is C. That's the biggest triangle. For this small triangle at the bottom, the single is B, the 90 is D, and the double is C. And then for What's another color we can use? For this the small top triangle, the single is A, the 90 is D, and the double is the B. So I'm going to go through and put all the values in that I know for each part. For the biggest triangle, AB is Y, AC is X plus 3, and BC is not labeled. For the triangle on bottom, the bottom small triangle, BD, that's this line in the middle, that's 4. DC is 3. And BC, they didn't tell us, but if you know two sides of a right triangle, you can do Pythagorean theorem. 3 squared plus 4 squared equals c squared. So 25 equals c squared, so this side has to be 5. So BC here is 5. I can actually put that on the big triangle now too. BC has to be 5. And then AB is Y. Oop, that's the wrong spot. Sorry. AB is Y. AD is X. And DB over here again is 4. So we are looking for situations where we can solve. Here's the deal. We know all 3 sides of this middle triangle. So I'm just going to keep referring to that. We need to solve for X and Y. And I can do it. I don't even need that first triangle. I can do it based solely on these 2 triangles. Because I have a complete set here of 5. That's not the complete set. I have a complete set here of 3 and 4. So I know that 3 over 4 has to equal 5 over y. So 3y has to equal 20. So y has to equal 20 over 3. For x, same setup. 3 over 4, but this time it has to equal 4 over x. So 3x has to equal 16. So x equals 16 over 3. Got it. Next problem. The ratio of the sides of the pentagon is that. Find the length of the longest side if the perimeter is that. All of these, slap an X on it. We've done this in class a few times. We've talked about why that is. But at the end of the day, you slap an X on each number, and it adds up to the total, 152. I'm just going to type that in real fast. 5 plus 42 plus 10. That's going to be 57x equals 152. And I get x equals 8/3. So the longest side is the 22. So it's going to be 22 times 8/3. And that's going to get me an answer of 176 over 3. Make sure I did that right. 5. I did 3 plus 2 is 5, plus 20 is 25. 25 plus 22 plus 10 is 57. 152 divided by 57 times 22. Just checking my work real quick before I leave it. Got it. It's good. Question 7, lots of parallel lines. Every single section has to have the same ratio. Every single section. So AB, so we just go through, here we have a complete set. So 9 over A equals 3 over 2. So 3 and 9 reduce to 1 and 3. So A equals 6. Got it. We're going to use 3 over 2 every time. B over 4 equals 3 over 2. 2 and 4 reduces to 1/2. So B equals 6. Got it. Oh, that's fun. And then 3 over 2 equals C over 3. So 2C equals 9. So C equals 9/2. And there's your answers. Every single section's the same ratio. The smallest sides of 2 similar polygons are 25 and 36, respectively. What is the perimeter of the smaller polygon if the larger polygon has a perimeter of 315? So the smallest Okay, so we know that 25 corresponds to 36. Those are the smallest sides. The smaller polygon, what is the perimeter of the smaller polygon if the larger polygon has a perimeter of 315? So that's going to look something like this. Let me see here. Nope. I don't think there's any reducing we can do. So we just cross multiply 36x 315 times 25 equals 7875. Divide by 36, and I get x equals 875 over 4. So the smaller polygon has that perimeter. Remember, the polygon's perimeter and their sides have the exact same ratio. Number 9, how many more we got here? The bell just rang. All right, 9 and 10. We can do these. I'll open my door here in a second for the people that need in. Oh, parallel lines. All these sections have the same ratio, all of them. So if we know one section's ratio, we know all the sections' ratios. So give me just a second here. Sorry for this. Trying to make all these videos. How's it going, Audrey?
Good, how are you?
Doing pretty good. I'm making a little video here real fast. I'm going to be talking to the screen. We know that the ratios have to be the same between each section. So I'm going to use this 3 over 4 every time. 3 over 4 is going to equal y over 3. Nothing reduces, so 4y equals 9. So y has to equal 9 over 4. For the w up there, same ratio. 4 over 3 is going to equal 4 over w. Well, that means w just has to be 3. And then x, this is where people run into problems. X is on the parallel line. So you have to go to the triangle. X would go, the left of that triangle would have to go over the entire bottom of 7. And then that would correspond to, the only thing that it goes with is this 3, which goes with this 4. So left over bottom for that green triangle would equal left over bottom for that purple triangle. And nothing reduces, so you cross multiply. I don't have a lot of room here, but you would get 4x equals 21. So x equals 21 over 4. So there's your answers, 3, 21 over 4, and 9/4. And then we have another question here where we have all those right triangles. I'm going to do this one much quicker than the last one. Here's what we know. Make up a number that's probably the easiest way. Let's say that this corner is 80. That would make this corner 10. That would make this corner 80 and this corner 10. So I want to put a 1 dash on this corner, which means there's a 1 dash on this corner, a 2 on this corner, a 2 on this corner. I'm going to redraw all 3 right triangles. And I'm going to put them all in the same positions. I'm going to do a 1 dash, a 2 dash, and a 90 for all 3 triangles. There's no labels on this one, so I'm going to label the corners A, B, C, and D, and I'm going to get all my info in there. For the biggest triangle, the 1 dash is A, the 90 is, let me move this a little bit over so it doesn't look like it's there. The 90 is B, and the 2 dash is C. For this triangle on the right side, the 90 is D, the 1 dash is B, and the 2 dash is C. And for the small triangle on the left side, the 1 dash is A, the 2 dash is B, and the 90 is D. So once I got that in there, now I'm going to go through and put every measurement that I know. On the biggest triangle, AB is Y, BC we don't know, and then AC they're calling X. On the triangle on the right, BD is 8, DC they don't tell us, and then BC they don't tell us. And then on the smallest triangle, AD is 6, BD is 8. Well, Pythagorean theorem, 6 squared plus 8 squared equals 100. This side has to be 10. So that means y has to be 10. So we actually know the y value is 10. So we know AB is going to be 10. Got it. So we're just looking for x now, which we can do based on these two triangles. We know that 6 goes with 10, 6 goes with 10, and then 10 goes with x. Reduce, this would be 3/5. So 3x equals 50, x equals 50 over 3. And what do we say y equals? Y equals 10. The Pythagorean theorem is the key here, guys. If you don't do the Pythagorean theorem, you're going to be stuck there for sure. Redraw the triangles, find the proportions. And that's it on that one.